Okay, welcome back. Now here's definition 1 of simple harmonic motion. Okay, so the definition says that a point that moves on a coordinate line is in simple harmonic motion when its distance d from the origin at time t is given by either of these functions. D is equal to a sine omega t, sine of omega t, or d is equal to a cosine omega t, where a and omega are real numbers such that omega is positive, greater than 0. Okay? So this is the definition of simple harmonic motion. And again, this could be harmonic motion in up and down in the y direction, or it could be harmonic motion, simple harmonic motion in the x direction. Okay? For example, if you had a vehicle or something, a block attached to a spring, and you're pulling the spring along a surface, right? Assuming again, friction is negligible and air resistance is negligible, right? Same conditions, right? Or same assumptions. Okay, so also, when we have this, we also have these definitions here. So we would define amplitude, right, is equal to, again, like we had before, the absolute value of A, right? The absolute value of A would describe the amplitude, period. And again, this should be familiar since from our previous videos, that the period is going to be 2 pi divided by omega. Okay? And then the frequency, by the way, the frequency is, remember, cycles per second, right? So the frequency turns out to be just the reciprocal of the period. Omega divided by 2 pi, right? How many times does it take it to go one cycle, right? Cycles per second, right? So here you got 1 revolution divided by omega, right? That's where we get the period from. And then of course, if we take the reciprocal, that's going to give us the frequency, right? Remember, this is how long it takes to go 1 cycle. That's the period. This is the number of cycles per second. So if you know the period, you just take the reciprocal of the period and you get frequency. Okay, so that's the definition. And now we'll come back, we'll do an example and checkpoint. Bye.